Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video, I am going to explain how you're going to answer the questions for IGCSE Chemistry 0620 March 2022 paper 42, which is a extended version. I'm not going to explain the instructions as you already know that you have to attempt all the questions and periodic table is printed in the last in the question paper. Let's begin the paper. Question 1 is about the first 30 elements in the periodic table. Name the element which is 78% of clean, dry air. It's easy, as you know, 78% of clean, dry air is nitrogen. B has atoms with an electronic structure of 2, 8, 1. The answer is sodium. Because if you add these numbers, you will get 11, which is the proton number of sodium. And you know that for any neutral atom, the number of protons are always equal to the number of electrons. For C is extracted from hematite. Hematite is the ore of an iron. So the answer is simply iron. D forms an oxide with a giant covalent structure. In case of D, you know that there's only one element, in fact, non-metals in your syllabus, which makes oxide with giant covalent structure, and that is silicon. E is a gas with the slowest rate of diffusion at room temperature. Recall all the gases from first 30 elements, and these will be N2, O2, F2, Cl2, He, Ne, and Ar. Now calculate their relative molecular mass and atomic masses. You will find that chlorine will be the one with the highest mass, which means that it is the gas with the slowest rate of diffusion. I will do the calculation for Cl2. Its Ar is 35.5. Multiplied by 2, you will get 71. F has an anhydrous chloride which turns pink when water is added. It is anhydrous cobalt chloride. It's a salt which turns pink when water is added. So you write cobalt. G has aqueous ions which forms a white precipitate when added aqueous silver ions. Answer is simple, should be chlorine because it is the only ion which gives white precipitate with aqueous silver ions. H forms blue hydroxide which dissolves in water. The answer is copper. Copper gives blue hydroxide when reacted with aqueous ammonia, and it's also soluble in excess of ammonia. For this one, is added to molten iron to remove impurities in the steel making process. You can't write limestone because during extraction of iron from its ore, limestone is added along with the iron ore. Oxygen is added to molten iron to remove impurities. During the steel making process. J is used to galvanize iron. We know that zinc is the element that is used during galvanization. Question number 2, student adds aqueous large pieces of magnesium carbonate MgCO3 to dilute hydrochloric acid HCl and measure the volume of carbon dioxide gas CO2 given off. Add the missing state symbols to the chemical equation for the reaction. It is clear from the question that magnesium carbonate exists in the solid state, so you will write S here. And we know that acid or alkalis exist in the aqueous state. H2O exists in the liquid state, so you write L here. For CO2, you write G as CO2 is carbon dioxide, and it exists in the gas state. Part B. Complete the dot and cross diagram to show the electronic arrangement of the ions in magnesium chloride. The inner shells have been drawn. Give the charges on the ions. You have to show all the outer valence electrons of both magnesium and chloride ions. You will show the 8 outer electrons of magnesium ion with cross and place +2 or 2+ like this. 1, 2, 3, 4, 5, 6, 7, 8. In case of both chlorine or chloride ions, show 7 outer electrons with dots and 8 one with the cross, as it is coming from the magnesium ion. 1, 2, 3, 4, 5, 6, 7, 8. Put minus here. This one. 1, 2, 3, 4, 5, 6, 7, 8. Put the chart. Part C. Complete the dot and cross diagram to show the electronic arrangement in a molecule of carbon dioxide. Show outer electrons only. This one is easy. You can use dot and, or cross for either oxygen or carbon. Remember this, that a carbon atom needs 4 electrons to complete its valence shell, and each oxygen atom needs 2 electrons to complete its valence shell. It means that a carbon atom will share 2 electrons with each oxygen atom, and each oxygen atom will be sharing their 2 valence electrons with the carbon atoms. For carbon, 1, 2, 3, 4. For oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you count the number of electrons for each oxygen atom, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. For carbon atom should be 8. It should also be 8. 1, 2, 3, 4, 5, 6, 7, 8. Part D. The graph shows how the volume of carbon dioxide gas changes with time. Part 1. Describe how the graph shows that the rate of this reaction decreases as time increases. Graph clearly shows that this gradient of line decreases, which indicates that the rate of this reaction decreases. So you write gradient of line decreases. Number 2, explain in terms of particles why the rate of this reaction decreases as time increases. Graph indicates that the concentration of particles of acid decreases. Concentration of acid decreases. Note here that you cannot write magnesium carbonate because it is in excess, and hydrochloric acid is obviously in limited quantity or concentration. And the last statement will be lower rate of collisions of particle. Lower rate of collisions of particles. For 2D part 3, student repeats the experiment using powdered MgCO3 instead of large pieces. All other conditions stay the same. On the grid, draw the line expected when powdered MgCO3 is used instead of large pieces. Remember, powder form have large surface area than large pieces. Therefore, the rate of reaction will be faster. So you will make a new line steeper than printed line like this. This bit steeper. And the line levels off earlier than printed line levels off at the same volume. Part E. Determine the volume of CO2 gas given off when excess MgCO3 is added to 25 centimeter cube of 0.4 mole per dm cube HCl at room temperature and pressure. This is a reaction. MgCO3 plus 2HCl gives MgCl2 plus H2O plus CO2. Use the following steps. Calculate the number of moles of HCl in 25 centimeter cube of 0.4 mole per dm cube of acid. According to the information given in the question, 100 centimeter cube contains 0.4 moles of acid. So I will write 100 centimeter cube contains 0.4 moles acid. Therefore, 25 centimeter cube contains x moles. So the answer will be 0.01. This will be the calculation. 25 multiplied by 0.4 divided by 1000. Next one, determine the number of moles of CO2 gas given off. In next one, you need to calculate moles of CO2. According to the reaction, 2 moles of acid gives 1 mole of CO2. 2 moles of acid gives 1 mole of CO2. Therefore, 0.01 moles gives x mole of CO2 will be like this: 0.01 multiplied by 1 divided by 2. So the answer will be 0.005 moles. Now, in the last part, calculate the volume of CO2 given gas given off in centimeter cube at room temperature and pressure, which will be like this. Very easy. 0.005 multiplied by 25. The answer will be 120 centimeter cube. Question 3 is about nitrogen dioxide. In part A, they want you to explain how nitrogen dioxide is produced in car engine. In your answer, you have to mention about both nitrogen and oxygen coming from air reacting due to high temperature. So the final answer will be like this: nitrogen from air and oxygen from air react. And the second line, react due to high temperatures of engine. In part B, nitrogen dioxide causes respiratory problems. State one other adverse effect of nitrogen dioxide. You have to write any one adverse or harmful effect of nitrogen dioxide. They have already mentioned respiratory problem. Therefore, the other adverse effect will be acid rain. Part C, nitrogen dioxide emissions can be reduced by adding an aqueous solution of urea, NH2, or twice CO to car exhaust gases. The heat of the exhaust gases breaks down the urea into simpler substances. Name the type of reaction which occurs when a substance is heated and breaks down into simpler substances. Now they are asking about the type of the reaction. Answer is very simple, that is thermal decomposition. Thermal means related to heat and decomposition means breaking down of a substance. Part 2, one molecule of urea breaks down to form one molecule of ammonia and one other molecule. Complete the chemical equation to show the formula of the other molecule formed in this reaction. This is the reaction NH2O twice CO gives NH3 plus. Now, one of the product is mentioned here, that is NH3. According to the formula, HCNO is left, which is the final answer. Now, in part 3, you have to write down the test and observations for ammonia. You know the test for ammonia, that is red litmus paper. Don't just write red litmus paper. You have to mention damp red litmus because it will only give test of ammonia if it is damp. Damp means moist or with water. So the final answer will be damp red litmus. Damp red litmus. In the observation, you write litmus turns blue. Part D is about balancing the equation. The ammonia formed reacts with nitrogen dioxide to form nitrogen water. Balance the equation for this reaction. Here's a reaction. Now, the best way to do this question is to make a column mentioning all the atoms. Now, count the number of atoms of each element on both sides of the equation. You'll see that nitrogen is balanced on both sides of the equation. What about oxygen and nitrogen? Oxygen and hydrogen. Oxygen is 2 on reactant side, but 12 on product side. And the hydrogen is 3 on reactant side, but 24 on product side. If we place 6 before NO2 and 8 before NH3, then both oxygen and hydrogen will be balanced. But then we need to balance nitrogen on product side. Simply place 7 before N2. Now this equation is balanced. Part 2 state how the equation shows that nitrogen dioxide is reduced. Very simple. You simply write nitrogen loses oxygen. Nitrogen loses oxygen. Next part, the reaction. This reaction is a redox reaction. State the meaning of the term redox. The conceptual reduction oxidation occur. Simple as that. Reduction and oxidation occur. Now, in E, 135 moles of urea NH2 whole twice CO is stored in the tank of a car. Calculate the mass in kilogram of the stored NH2 whole twice CO. Here, just multiply with number of moles with the MR of urea, which is 60. Answer obtained is in grams, so divided by 100. Divided by 1000 to get the answer in kilogram. MR urea 60, 135 multiplied by 60. Right answer 1000. You get 8.1 kilogram. Now, on part F, another oxide of nitrogen formed in car engines is nitrogen monoxide, NO. A catalytic converter removes NO by reacting it with a gas formed by incomplete combustion of the fuel. Two non-toxic gases are formed. Part 1, name the gas formed by incomplete combustion of the fuel. This one is very simple. You know that during incomplete combustion, both steam and carbon monoxide is produced. Question indicates that the gas produced must be the toxic one. So the answer should be carbon monoxide. In part 2, name the two non-toxic gases formed. Now they are asking about the non-toxic gas produced in the catalytic converter. So the answer will be carbon dioxide and nitrogen. Carbon dioxide and nitrogen. Now, question number 4. This question is about chemical reactions and electricity. Part 8, the diagram shows the apparatus used in the production of electrical energy in a simple way. You see the diagram. We have zinc electrode on left side, iron electron right hand side. This is a voltmeter, and you have electrolyte. The zinc electrode dissolves in the electrolyte, forming Zn2 plus aqueous ions. Number 1, draw an arrow on the diagram to show the direction of electron flow. So you have to remember the reactivity series. You can remember this. K Karachi, nice, charming, magnificent. All caring. Zinc friendly home. zinc, friendly, chrome, copper, silver, gold. Copper, silver, gold. So, where do you zinc? The movement of electron will be from zinc to iron. According to this, zinc is more reactive than iron. So the flow will be like this. Part two, write the ionic half equation for the reaction that occurs when the zinc electrode dissolves. So as zinc is the only reactant here, so therefore it will lose electrons from Zn2 plus ion. So the answer will be like this. Zn gives Zn plus 2 electrons. So yeah. Now this one part B, the reading on the voltmeter can be increased if either zinc or iron is replaced by another metal. Name a metal that can replace zinc and increase the reading on the voltmeter. You can write any metal above zinc, but I suggest you don't choose metals like sodium, potassium because they are highly reactive. You can write calcium, magnesium, or even aluminum. For part two, name a metal that can replace iron, increase the reading of the voltmeter. You can add any metal which is below iron. We have copper, silver, gold. Fuel cells are used to generate electricity. Name the reactants in a fuel cell. We know that's hydrogen and oxygen. Name the waste product of a fuel cell as this hydrogen and oxygen, so the product is water. Electricity can be used to break down aqueous or molten ionic compounds. Part one, name the process which uses electricity to break down aqueous or molten ionic compounds. This one is very easy. We know electrolysis is a process which breaks down aqueous or molten ionic compounds. So you'll write electrolysis. Part two, explain why the ionic compound needs to be aqueous or molten. We call the idea of free moving or mobile ions for the conduction of electricity. So the answer will be mobile ions. E. Brine is concentrated aqueous sodium chloride. Name three substances which are manufactured by passing electricity through brine. It's very easy. We get hydrogen on cathode as it is higher than sodium in the reactivity series. Chlorine because high concentration of chloride ion, and sodium hydroxide because of the sodium and hydroxide ion in the solution. Part 2, name a different substance formed when a molten sodium chloride is used instead of concentrated aqueous sodium chloride. Sodium, you use molten form, so you'll get sodium. This question is about alkanes and alkenes. Short chain alkanes and alkenes can be formed from long chain alkanes in a chemical reaction. Name the type of chemical reaction which forms short chain alkanes and alkenes from long chain alkanes. There's only one reaction in your syllabus, and that is cracking. So you write cracking here. Number 2, decane has 10 carbon atoms. It forms ethane and ethene as the only products in this type of chemical reaction. Write the chemical equation for this reaction. You know the formula of decane. Recall the general formula of alkane, which is CnH2n plus 2. If you will put the value of 10, what you will get? You will get C10 H2 multiplied by 10, 20, 20 plus 2, 22. So we'll write C10 H22. We are cracking C10 H22. And the products they have mentioned ethane and ethene. Simply write the formula of ethane and ethene first. The formula of ethane is C2H6. Ethene is C2H4. Now we have to balance this equation. If you look at the formula of the reactants decane C10, we have 10 carbon atoms, and on the product side we are having 4 carbon atoms, so it means we have to add 3 more carbon atoms. So what if I'll write 4C2H6? If I'll write 4C2H6 plus C2H4, count the number of carbon atoms. 4 2 is 8, 8 plus 2 10. What about hydrogen? 6 4 24. So it's not possible. This is wrong. What if I will write 4 before C2H4? Let's do this. C2H6 plus 4 C2H4. Count the hydrogen atoms, carbon atoms first. 4 2 is 8, 8 plus 2 10. What about hydrogen? 4 4 16, 16 plus 6 22. So this will be the right answer. So you write 4 here. Part B. Ethane reacts with chlorine at room temperature to form chloroethane, C2H5Cl, and one other product. Name the other product formed. It's very easy. It's a substitution reaction of ethane. The other product is hydrogen chloride. As you are reacting with chlorine, so you will get hydrogen chloride. If you are reacting with bromine, you will get hydrogen bromide. State the condition needed for this reaction to take place. Ultraviolet light. It's a free radical reaction, so it takes place in the presence of ultraviolet light. In fact, it's an example of photochemical reaction. Photochemical reactions are those reactions which are catalyzed by light. Ethene reacts with chlorine at room temperature to form dichloroethane, C2H4Cl2. This is the reaction. C2H4 plus Cl2 gives C2H4Cl2. State why this is an addition reaction. Answer is very simple. Only one product is formed. Only one product is formed. Next part, this is a reaction. This question, the chemical equation for this reaction can be represented as shown. This is displayed formula of ethene. This is chlorine, and the product is dichloroethane. The energy change for the reaction. The energy change is given minus 180 kilojoule per mole. Use the bond energies in the table to calculate the bond energy of a CCl bond in kilojoule per mole. Use the following steps. Step number 1, calculate the energy needed to break bonds. So we are having ethene and Cl2. How many bonds of CH are broken? 1, 2, 3, 4. So you will multiply 4 by CH bond energy is given 410 plus C double bond C is given 610 plus CL bond is also given 240. What we will get? We will get 2490. Use your answer in step 1 and the energy change for the reaction to determine the energy release when bonds are formed. We know the formula. The formula is overall energy change is equal to energy required to break bond, we have already calculated, plus energy released, bonds made, bonds are, we need to calculate this. So overall energy change, what is it? It's given here, sign is also minus 180. We'll write minus 80 here. Minus 180 gives energy required to break bond is 2490 plus x. So x is equal to minus 180 minus 2490. Sorry, there's a mistake. The sign is minus here. So definitely this one is also minus. So the answer is minus x is equal to minus 2670. So the final answer 2670. Use your answer in step 2 and bond energy values to determine the energy of the CCl bond. If you look at the data table, CC bond is given, CC and CH bond is given. So what we will do? We will add up these bonds. We have one CC bond and 1, 2, 3, 4, 4 CH bond and 2 CCl bond. So we have 2x for CCl, as there are 2 bonds, plus the CH. What about CH? 4 into CH bond 410. 4 into 410. 4 into 410 plus CC is also there, only one CC. So it's 350 plus 350. And it should be subtracted from 2670. Sorry, it should be equal to 2670. So we will get what we will get. We will get 2x is equal to 2670 minus 1990, and 680 will be the answer. Then we'll divide 680 by 2 in order to get the value of x. So it will be 340 kilojoule per mole. The names of 4 esters are listed: methyl propanoid, ethyl propanoid, propyl propanoid, butyl propanoid. Esters are a family of organic compounds with similar chemical properties. They can be represented by the formula CnH2 and O2. State the name given to a family of organic compounds with similar chemical properties. The general term use homologous series. Explain why members of a family of organic compounds have similar chemical properties. Only one reason: they all have same functional group. State the name given to a formula such as CnH2 and O2. It's journal formula for the family esters. Determine the value of N in butyl propanoate. Butyl means 4 carbon, propane means 3 carbon. So N should be 7. All 4 of the esters in the list are liquids at room temperature. Name the technique used to separate ethyl propanoate from a mixture of the 4 esters, fractional distillation. Fractional distillation involves the separation of miscible liquids. They are miscible liquids. All four esters can be made by reacting different alcohols with the same substance. Name this substance and draw its structure. Show all of the atoms and all of the bonds. Name, structure. It's propanoic acid. Very easy, propanoic acid. The reason is that we are getting propanoate. Propanoate is coming from propanoic acid, and the alkyl group is coming from alcohol. So we have to draw the structure of propanoic acid. There are three atoms of carbon, 3, 1, 2, 3. The third one will definitely carries the functional group, that is COOH. I'm showing each bond. Name the alcohol used to make methyl propanoate. Methyl, alkyl is coming from the alcohol. So we have methanol. Other esters not in the list have the same molecular formula as propyl propanoate, but different structures. State the term used to describe substances with the same molecular formula but different structures. They are called structural isomers. Name two esters with the same molecular formula as propyl propanoate. You can have ethyl butanoate, you can have butyl ethanoate. Polyesters can be made from the two different molecules shown. Complete the diagram to show a section of the polyester made from these two molecules. Include all of the atoms and all of the bonds in the linkages. So if you look at the shaded, this one, it's carrying COOH. So what you will do, you will write COO here. On the other side, you also show COO. In fact, when you are drawing, this one is coming here, and in this one, we'll get this chain bond O. Chain bond O. So it's alcohol. Again, you are having same chain bond O, C double bond O, COO, O, so on. Name the type of polymerization that takes place when this polymer forms. So where is its condensation polymerization? Because it involves the release of a simple molecule like water, sometimes HCl. Name a polyester, it's terylene. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.